Today we're looking at sequences. Chapter 1, Section 1.1 is about recursively defined sequences. Our objectives for today, we want to be able to identify arithmetic and geometric sequences, and we want to be able to create recursive formulas for sequences. First of all, we have to define what a sequence is. A sequence is simply an ordered list of numbers. Okay. And actually things like, 2, 4, 6, 8, 1, 3, 5, 7, 9, those are sequences. We also could have one that looks like this. It would be 1, 5, 9, 13. And a dot, dot, dot usually indicates that it keeps going. Okay. These are called the terms of a sequence. And in this case, we have certain notation that we use. We write this. We call this, we say U sub 1. U sub 1 is the first term. And the first term of this sequence is 1. We could say U sub 4. U sub 4 would be the fourth term of the sequence. 1, 2, 3, 4. That would be 13. Now, if we want to identify a term of the sequence without by number, we could say U sub n is the nth term. So that means it could be any term. Okay. And now, we also have one that's U sub n minus 1. And some people always shake their heads and go, what? U sub n minus 1? What is that? Okay. That is the term before U sub n. Just to help us understand that a little bit, okay, if we have a term of U sub 9, the term before is U sub 8. If we have U sub 114, the term before is U sub 113. Everybody understands that. The idea, the same thing, but aren't we just subtracting 1? 114 minus 1 is 113, 9 minus 1 is 8. So if I have U sub n, I need to do the same thing to get that term before. So that's why I do U sub n minus 1, because this is U sub 114 minus 1, and this is U sub 9 minus 1. Those terms are the same, and that's where the terminology U sub n minus 1 comes from. Okay? So we want to be able to make a recursive formula. We want to use a recursive formula and we want to use it to define a sequence. We want to use it to define a sequence. Okay, so back to our example of 1, 5, 9, 13. What we're going to need to do to define this sequence, we have to have two parts. We have to identify the first term. We have to identify the first term. I'm going to show you why that is in a minute. And then we have to write a recursive rule that defines U sub n in terms of previous terms, okay, or it could be just in one term, such as U sub n minus 1. So there's two parts. So for our example, we need to identify what our first term is. We always need to identify our first term. In our first term, U sub 1 is 1 in this case. And then the recursive rule is just a mathematical description of the pattern. What are we doing to get our sequence? Are we adding the same thing each time? Are we subtracting? Are we multiplying? And in this case, to go from 1 to 5, we have to add 4. 5 to 9, we're adding 4. 9 to 13, we're adding 4. Our pattern is that we are adding 4 each time. So what we say is that U sub n equals U sub n minus 1 plus 4. Now it's very important that you have both parts of this. This describes the pattern, and this describes where to start. If we only have the 1, many kids they'll forget about the use of 1 and think that it's not necessary, but it is. Let me show you an example of why. Okay? Let's say I have this sequence. So, okay. If we look at this sequence, we are adding 4 each time. I'm adding 4, adding 4, adding 4. And so the pattern is the same as the original sequence that we did here. Well, if I only give you the pattern, now you don't know if I'm talking about the sequence 1, 5, 9, 13 or the sequence 14, 18, 22, and 26. That's why it's very important to put u sub 1, in this case it's 14, and our pattern u sub n equals u sub n minus 1 plus 4, that identical pattern. Okay? Identical pattern, which is okay. But now, with both parts, these are two new unique sequences. Right? These are both examples of arithmetic sequences, what's called an arithmetic sequence. Which an arithmetic sequence is determined by adding or subtracting a constant. Okay. So, for example, the first time we said we were adding 4. We could subtract 3. We could subtract 1.5. But it looks like this. We have a common difference of d, in the sequences that we've seen, that common difference was 4. And we have u sub 1 equals some number. U sub n equals u sub n minus 1 plus d. And d can just be negative if you want it, in order for it to be subtraction. Right. We also have what are called geometric sequences. A geometric sequence, instead of repeated addition, these are determined by repeated multiplication. Okay. So we will have something like this. U sub 1 equals a number, and u sub n equals u sub n minus 1 times r, where r is our common, instead of a common difference, it's a common ratio. A common ratio. Okay. So, an example. We have a sequence 2, 6, 18, 54. Right? Most of the time when you have a sequence, they will not tell you whether it's geometric or arithmetic. You have to determine that for yourself. What they're going to ask us to do here is to write a recursive formula. Okay? Write a recursive formula. So we looked, we see, okay, well, if I do 2 plus 4, I get 6. 6 plus 4 would give me 10. Well, that doesn't work because they're not doing the same thing each time. So now I look to multiply. 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. So the pattern here is I'm multiplying by 3 each time. A very quick way is to take each number and divide it by the one in front of it. So 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18 is 3. So if we want a recursive formula, we still need u sub 1, and that's 2. And then we need to describe the pattern. So u sub n equals u sub n minus 1, and the pattern was times 3. That is our recursive formula for that particular sequence. Okay? This would be a good time to talk about recursion. Recursion is an important idea, especially in computer programming. If you're interested in computer programming and things like Candy Crush uses recursion. The idea of recursion is we take something, we do something to it, get an answer, and then we do it again. So in the case here, we multiplied by 3, we got an answer of 6, then we multiplied by 3 again, then we got an answer of 18, then we multiplied by 3 again. That is the idea of recursion. We keep getting our answer and putting it right back in and doing the same thing that we already did. And as I said, games like Candy Crush or Bejeweled all use recursion in order to work properly. Okay, I'm going to give you a couple work examples. Okay. I'll give you a couple sequences here. You can pause and do them for yourself, and then you can come back and check to see if you got it right. So let's see, number 1. And number 2. Okay, if you want to pause and then come back here, you can look at those 2 examples and try those on your own, and you come back and see how you did. All right. So now we'll work them out now. So we can see that, first of all, u sub 1 is 11, first term. We can see that we are subtracting 3 each time. Our pattern is subtracting 3. So u sub n equals u sub n minus 1 minus 3. That's our pattern. In the second one, we are multiplying by 5. Okay. And so our u sub 1 is 1, and u sub n equals u sub n minus 1 times 5.